Hey everybody, this is Games Plus James and welcome back to another Unity tutorial. And today we're going to take a look at how to create a arcade style car controller in Unity. It's relatively simple to do and it's a lot of fun to play around with and have a bit of fun along the way. This system that we're going to use is inspired by an idea I saw a good long while ago now from Kenny, if you follow him on Twitter, who has also provided these spectacular free racing assets that we have in our little scene here. And how this system works is essentially, it looks like we're driving around this little car here, but if I just pause this for a second, you can see here, there's a sphere here. If we stay not inside this view, with this sphere highlighted, if I press the button here, the sphere is actually the thing running around. If I turn on the gizmos here, the sphere is what's rolling around in the world, and we're just following around behind it, and it actually creates this rather fun and arcadey feeling movement. And before I dive into explaining how this all works, don't forget that you can go to Steam and wishlist our game Skoot Kaboom and the Tomb of Doom, which you can see on screen right now, and you can add it to your Steam wishlist for free. It's not a problem at all. It doesn't cost anything to add it in there, but it really helps the game out. It helps the game get added higher into Steam's algorithms, so it really helps push things higher and it will help the game upon its actual release. So even if you don't know if you'll be able to actually buy the game when it comes out, just adding it on Steam really helps the game. So let's go ahead and move on and dive into making this arcade car controller work. Okay, so I've got a starter project here with all these various different assets set up. There'll be a link in the description if you want to use the exact same project yourself, or you can just use some basic cubes or anything you want to use really. But we've got this set up here, but the most important element is we've got our car. And what we're going to do with the car is, as we saw a few moments ago, we're going to add a sphere to it, which is going to act as the actual physical thing that we use in the world. So I'm going to go to my car here, I'm going to create a 3D sphere, and I'm going to remove the mesh renderer because we don't need to see it. And I'm going to set the radius of it slightly smaller to be 0.45. And then we're also going to give it a rigid body. So I'm going to add component and I'm going to add a rigid body to it. And I'm going to set some settings on this that I've just played around with and found to work nicely. So we've got these various different amounts here that are going to just apply to the ball. And you can play around with these values and see what different effects you get, and it will affect the handling of the car, but it's mostly just there for us to be able to use as a starter value. Okay, so we've got our sphere in the world. What we then need to do is actually make it do something. So let's go ahead and add a script to this. So I'm going to go into my scripts folder and I'm going to create a C# script that we're going to just call car controller. And I'm going to attach it to the car itself, not to the sphere. So we're going to go to the car and attach that there. And then I'm going to open this up in Visual Studio. So in our script, essentially what we're going to do is move that rigid body in the world and then move our car to be at the position of the rigid body. So we're essentially going to follow wherever the rigid body is in the world. So for that, we're going to need a couple of references, first of all, that we're going to set up for us to use. So I'm going to, first of all, create a reference to the sphere that we have. So this will be public rigid body. And our sphere is going to have the rigid body on it. So I'm just going to refer to this as the rigid body that we're using. And we're also going to add some basic inputs that we're going to use. So for example, we're going to add some public float values that we'll call forward accel for forward acceleration and reverse acceleration. We're going to have the maximum speed our car can go, and we're going to have a turn strength, and that's going to be how much turning we can do at any particular time, so how fast we want our car to turn. So let's just set it up first of all so that when we move the rigid body, it will we'll make our car go to where the sphere is in the world. So because this is a physics thing and because we're using such a heavy amount of physics movement, we're going to do most of our physics stuff in the fixed update. So I'm going to go to void fixed update here. And just for a moment, just to test some things out, I'm going to add some basic movement to the sphere. So I'm just going to throw some rigid body. We're going to add a force. And the force we want to do is just transform.forward multiplied by, let's just say, our forward acceleration. So this will just make the car move forward. or make the ball move forward relative to the car. And then in our update, in here is where we're going to say transform dot position equals the rigid body dot transform dot position. So we're going to move to wherever the rigid body is in the world. So let's just save this and we'll go back into Unity. Actually, just before I save it, I'd set up some default values in here. So our forward acceleration, we'll say we'll have 8 to start off with. Just set these up so it's easier to know where we are. 4 for reversing. Let's say our maximum speed to 50. And our turn strength is going to be pretty high. We're going to set this to 180. So I'm just going to save this and let's just jump back in here and let that compile. And if I play, we should see, oh no, wait, I didn't assign the rigid body. Here we go. Assign the sphere to here. And we're going to notice one issue that will happen. If I play this now, we're rolling forward. That works pretty fine. We're going pretty slow, but we'll worry about that later. But you can see there's a bit of jittering there. And that'll happen a few times because we're also going to be getting kind of double speed movement. Because what's happening here is, if we look at our car, when our sphere moves forward, it moves forward to here, say. If our car object, our transform position of the car, tries to move forward to the same place, it'll go to where the sphere is, but you'll notice now the sphere has also moved ahead because the sphere is a child of the car. So we're actually getting double movement happening here, which obviously we don't want happening. So I'm going to undo both of those, make sure our sphere is back at 0, 0, 0. There we go. And what we're going to do is, as soon as the game starts, we're going to say, okay, the rigid body dot parent, rigid body dot transform dot parent equals null. So that it is no longer parented to the car and it's freely moving around, but we're still following it because we have the reference to it here. So you might have noticed also, well, you might have noticed I did specifically say we were moving very, very slowly there. And that's because when we apply forces to a car like this, or to an object, the forces it mounts are actually being applied very, very low levels. So what I found to work very well for this in general is to multiply whatever we put in there by 1,000. Now, obviously you could enter 8,000 up here and just leave this without the multiplier here. But I find it's better in the Unity inspector to have smaller values that look more reasonable rather than saying, hey, my acceleration is 8,000. It's a bit kind of abstract and hard to understand. So instead, we just put it at 8 and then multiply it in the code by a much higher value. So now if I go ahead and play, we'll see, there we go, the car zooms off quite fast. So we are still getting some of that jittery as well, and we can fix that by setting the interpolation here to either interpolate or extrapolate. So if I go ahead and play, we'll see, there we go, it's much more smooth movement now. But the car is now moving the way we want it to. If I unmaximize this here, we can play and we'll see that the sphere is no longer childed to it. So there we go, the sphere is a different object in the world, but it's zooming away and our car is following it correctly. So the next thing we need to do is start taking some input. So how we're going to handle input is, obviously we want our physics to all happen in fixed updates. So we want to apply any forward motion or back motion in the fixed update. But generally speaking, it's not good to take input from during the fixed update function. You want to take input during the update loop. So what we're going to do is create two values up here. So we're going to have a private float for our speed input and one for our turn input. So this will be just a way of storing the input we do. And then in the update loop, we're going to say, I'm going to leave setting the position to be the last thing we do in the update loop. So first thing we're going to do here is say, at the start of every update loop, we're going to set our speed input back to being 0. So speed input equals 0. Then I'm going to do a check and see if we have any input on the vertical axis. So we're going to say if input.getAxis vertical. So if we're pressing the up or down arrows are W and S is the normal setup. So if our vertical is greater than 0, so if we're pressing up or forward, then we're going to tell our speed input should be equal to that getAxis value. So input.getAxis vertical, and we're going to multiply that by our forward acceleration and multiply that by 1,000. or sorry, not 100, 1000. There we go. So then I'm also going to say otherwise, so else. We'll do another if check. We're essentially going to do the same thing. So I'm going to copy it all and just paste it in there. But this time we're going to say if it is less than 0, so if we're below 0, then set the speed input to be that multiplied by the reverse acceleration, because we want to accelerate a bit slower when we're going backwards. Okay, so now that we have that input, let's apply it to the car. So in here, we're going to say, let me just delete that for the moment. We're going to say if our speed input, so the amount of speed that we have going in, we want to say if it's greater than 0. Now, obviously, if we're reversing, it'll be less than 0. So let's change this to say if mathf dot absolute of this is greater than 0. So basically, we're saying, hey, if there's any input going on at the moment, then we're going to apply some force to our car. So we're going to say the rigid body dot add force, and we're going to make it move forward. So transform dot forward multiplied by our speed input. So whatever speed input we're applying. So let's save this and see this in action. Save it. We'll go back in here. We'll let it play once it's finished compiling. And now I can control the car moving backwards and forwards. Okay, so that's perfect. But what about rotating? Now, obviously, if I have my sphere highlighted and I turn my gizmos on here, with the sphere in our scene, if I start trying to turn this sphere, it'll start rolling around all over the place, because if we try to turn it on a certain axis, it's going to start getting very confusing for it to move around. So instead, what we're going to do is simply rotate the actual car object, because if I rotate the car now, we've already used the transform forward of the car to apply forces to the sphere. So if I go ahead and rotate the car here, so if I turn it like this, and now I press forward again, now we're going this way. So again, if I turn it just a little bit, now we're going forward. So we can just rotate the actual car and it will apply the same forces forward, and it will push us forward in the direction that we want. So let's stop this running. Let's go back in here. And because we're not actually doing any physics when we do this, we're simply turning the car in the game. We're just going to do this in the update section. So in here, I'm going to say our turn input equals input dot get axis horizontal, like so. And then we're just going to say that our transform dot rotation is equal to, and essentially what we want to do is add on the amount of turning that we're doing. So we're going to say it's equal to quaternion dot Euler, which is how we access quaternions as just an x, y, and z value, because you should know that quaternions are forward number values. If you don't know how that works, first of all, quaternions are complicated and they're a hard math thing to work your head around. So if I go to debug here, you can see rotation here is actually stored as x, y, z, w, which can be confusing, and they're all values between 0 and 1. So we don't want to mess around with that though. We want to just deal with it as if it's just an x, y, and 0 or x, y, and z value, because if I go to the car here, we want to rotate it. Oh no, I want to rotate it on one axis. Here we go. I'm going to rotate it around this axis like this, which is the y axis over here. So let's go back into our script, and here we're going to say, well, I want to take the existing transform.rotation.Euler angles, and I want to add on a new vector tree, and I don't want to make any changes on the x value. Where I do want to make changes is on the y value. So I'm going to take the turn input and I'm going to multiply it by the turn strength. So that's back up here. We set the value for how fast we want our car to turn, and then I'm going to multiply that by time.delta time, because we want this to happen at a fixed rate. And then finally, I'm going to say on the z-axis, I also don't want it to change, and then I can hit my semicolon at the end like so. I'm getting a bit of an error here. Oh, no, I put this on the wrong place. There we go. Perfect. Okay, so I can save that. Let's go back into Unity, and we'll see this in action. And we'll see one thing of why this won't... We'll have to make a slightly minor change to it, but we'll just play it first to see how it goes. So now, if I go ahead and drive I can turn, and immediately we get this nice kind of slidey effect. So straight away, this is the immediate kind of feeling that we want to have. Now obviously you can see, woo, look at me going flying like a crazy person. That's not great. We don't want our car kind of hovering around like this for so far. We're going to adjust that in a moment. But the other main thing we have is that if I'm stopped moving and I press sideways, look at this, we can turn as much as we want. So really we shouldn't be able to turn unless we're driving forward or backwards. And how we can fix that is simply by going in here and saying, when we apply this turn input here, we can just multiply it again by the input.getAxis vertical. So whatever vertical input we have. So essentially we're saying when there's no input, then we're multiplying it by 0. When the input is 1, then we can do a full turn. So when we're pressing forwards, we're able to turn completely forwards. But what's also interesting about this is when we're going backwards, so when it's -1, it'll flip the rotation around and it'll actually make the car behave when reversing the way you would expect it to. So I'm going to save this and let's go back into Unity and we'll see this in action. So if I go ahead and play here, when I turn, I'm trying to turn now and nothing's happening. If I go forward and turn, now we can turn exactly the way we want to, but I'm going to reverse now and turn right, and you can see the car reverses the exact way we would expect it to. It's kind of a little bit hard to see without the models for context here. Let's actually just zoom out and you can see the car a little bit better. So if I reverse the car here and turn, there we go, we're turning the correct way we expect it to. So perfect, that works nicely. So what we're going to do next is jump back into our script, and we need to make it so that when we're in the air, we come down to the ground a little bit faster. Now we could, for example, adjust the gravity in the project settings. So I could go to project settings here and go to physics and change the gravity amount here. But what I find works better is just applying some extra gravity to the car itself. So let's go back in here. And the first thing I'm going to do is create a force. So another float value up here called gravity force. And I'm going to set that to be 10 by default. And that's going to be how much force we use to push down on the car. And what we obviously want to happen is we want this to happen when the car is in the air. So when we're on the ground, we don't need to be applying this force to the car. So what we're going to do is create a private bool to keep track of whether we're on the ground. So private bool we're going to call grounded. And then what we're also going to do is shoot a invisible ray that will shoot a line from a certain point, and we're going to shoot it downwards to check if there's ground beneath the car. So for that, we need a couple of values to check what is the ground. So I'm going to have a public layer mask called what is ground. Then we'll have a public float to determine how long the ray should be. So ground ray length, which by default I'm going to set to be 0.5. And then I'm going to have another transform here for the ground ray point, which is where in space we want our ray to appear from. So before we write any code to do that, let's go back in and assign those values. So I'm going to let that compile. And there we go. So ground, I'm going to set this to be the ground layer, which I already have applied to all these objects in our scene. And the reason we do this is so that the ray will ignore the actual car itself. It won't collide with the car and say, hey, there's something here, which is the car, and telling us, hey, we're on the ground. But we don't want that. I've got a ray point set up here in the car, which is, if I grab our point here, is at this position in space, so slightly below the center of the car. And we're going to assign that into there. You can see on the ray point, actually, it's at minus 0.4 of where the center of the car is, which is right here. And it's shooting a ray of 0.5 down to the ground. So let's go back into our script then and make that happen. So in our fixed update here, before we apply any input or anything like that, first thing I'm going to do is at the start of every fixed update set grounded to be false. Then we're going to create a raycast hit that we're going to call hit. And then we're going to do a check and see if we do a physics.raycast. We need to do a couple of values in here. So first thing we need to do is tell it where to go from. So we're going to go from the ground ray point dot position. We tell it the direction we want it to go. So we want it to go down from the car. So I'm going to use the car's transform dot up value, which gets us the up direction, and I'm going to put a minus in front of that, which gives us the down direction based on the car. Then we're going to say out hit, which means it sends the result of the ray, and what it does, it gets stored in this hit value here. Then we need to tell it how long it is, so that'll be the ground ray length, and we need to tell it what we're checking for, and that is what is ground. So we're checking to see if we hit the ground. And then if all of that is true, so if the ray shoots out from the car downwards and it finds the ground, well then we know grounded should be true. And then what we're going to do here is say, when we do this input, we should only really accept input from the car when we're on the ground. So we're going to say if grounded, then we're able to drive forward and everything like that. But otherwise, we're going to say apply to the rigid body. We're going to add some force, which pushes it down into the ground. So that's going to be the rigid body to add force vector tree dot up multiplied by gravity force. So vector tree dot up would obviously be an upwards force, pushing it upwards, and when we multiply it by gravity force, that'll tell us how much force to add. So we're, instead of pushing it upwards, going to multiply it by minus gravity force, which will push it downwards into the ground, and I'm going to multiply that value by 100 this time. Okay, so let's see that in action. Actually, just before I see that in action, let's go back up here, and when we apply our rotation to the car, we also want that to only happen when we're on the ground. So I'm just going to add an if grounded check to this, like so. So we can only turn the car when we're on the ground. So let's go back in here now, save this. And if I play, now that we can't control the car in the air, we're going to see things a little bit different. But let's just drive forward here. I'm going to turn around. Let's get up this little ramp here. So when I drive up it, you'll still see we go off the edge and the car actually kind of stops. But you'll see we're falling down to the ground much faster now, which is what we wanted to do. But the problem is, now that we're not applying acceleration to the car when we're in the air, we see the car drop out of the air really fast. So we can fix that by going to the sphere here, and when we're in the air, we can basically tell the drag value here to go down to a really low number. So to do that, we'll need to obviously store the current drag value here in a value on our car. So let's go to our car controller. We're going to add another value up here, which is, let's call it the drag on ground value, and I'm going to set that to be 3 by default because that's what we have in our rigid body. And then down here, when we're on the ground, we're going to set the rigid body dot drag value to be equal to that, so it'll be equal to drag on ground. But when we're in the air, like we are here, we're going to set the rigid body dot drag value to be 0.1 f. So save this. Let's go back into Unity, and once that compiles, now when I play, if I just drive here and I just turn around and go back to this ramp here, and we drive up it, now we fly over the edge, and we're not flying too far, but we're getting a much better feeling. So I could mess around with the amount of force that's been applied when we're up in the air, and we get a much more kind of bouncy and more arcadey feeling effect going on right now. Okay, so that's most of the stuff working the way we want to, but one thing you should be noticing right now is that when we go up any of these ramps, our car just stays perfectly flat, which obviously really isn't great. We don't want our car just doing that. We want to make sure our car reacts to the surface that we have in front of us. So for that, it's very, very simple. I'm just going to stop this running here. Let's go back into our script. All we have to do is right here when we do our raycast, right below that, we're going to affect the transform rotation of our car based on whatever our raycast hits. So we're going to say transform.rotation is equal to quaternion dot from to rotation, which basically allows us to do some simple math to affect the rotation of the car. And all we do is tell it to change the up rotation of the car. So transform.up, we're adjusting that to be the hit dot normal. So the normal of whatever we hit is basically saying whatever the angle of the surface is that we hit against. So when we use hit.normal, we can use that, and then we'll also multiply that by the transform.rotation, there we go, that we already have. So that'll allow us to affect the turn that we have applied to our car. So now if I save this, very simple one line of extra code that we add in, we can go back in here, that is compile, and now if I play, once I get over to this little hill here and drive up it, there we go. Whoop. Well, if I didn't come in into it from the side, it would be a little bit better. So let's go ahead here. And now when I drive up the hill, there we go. You can see the car rotates to hit whatever ground it's touching against. And there you go. That's the basics of our arcade car controller working the way we expect it to. I can add a couple of little extra tweaks. I'm just going to do these very quickly. Let's make our wheels quickly turn. So I'm going to just add a couple of little values up here. I'm going to add a public transform left front wheel, right front wheel, and I'm going to add a public float max wheel turn. And then down here, when we are rotating the car, doesn't matter whether we're on the ground or in the air, I'm going to set the left front wheel dot local rotation is equal to quaternion dot Euler, and I'm going to take the left front wheel dot local rotation dot Euler angles dot x, because I'm not going to change that. I'm going to copy this whole line here. I'm going to adjust the y-axis, so I'm turning the wheels. So I'm going to use turn input multiplied by maximum wheel turn. But because this is the left wheel, it's going to turn the opposite way to the other wheels. The way the wheels are set up on the car here, I'm going to have to take away 180 from that. And then I'm not going to make any changes to the z value. So that's our left wheel done. I'm going to copy this to do the same for the right wheel, but obviously I'm going to replace left with right and left with right here and here, and I'm not going to take away 180 from it this time, so I can get rid of these brackets like so. So then I can save this. Let's go back into Unity. Actually, I'm just going to give this a default value of 25. So now if I go back in and save, oh, I need to assign the wheels to it. So on my race car here, I have the front left wheel, you can see already has a rotation of minus 180. So that's why I'm taking away 180 from the rotation we apply. But our front right just has a 0 rotation, simply because of the way the model was created. So if I go ahead and play, I can turn, and the wheels turn as I go. So now when I turn the car, the wheels look a bit more reactive. I've also got some dust trails that I can activate here on the car. So at the moment, if I just go ahead and play, we get a nice little trail effect behind us as we go. But obviously when I stop moving, I'd like those dusts to stop appearing. So I'm going to very quickly go back into my script, and I'm going to add another variable to handle those. So I'm going to add a public particle system. I'm just doing these quickly because this isn't really the focus of this video, but there are nice little extras that you can add in to add some extra effects to your car. So let's have a max emission value, which will be 25, and I'm going to add a private float to control the emission rate of the dust that's appearing. And then down here in our fixed update, I'm going to first of all set the emission rate is equal to 0. So there's nothing coming out. But then if we're moving forwards or backwards, then we're going to set the emission rate to be the max emission amount. And you notice this only happens when we're on the ground and moving forward. So also when we're in the air, there won't be any dust coming out. And then down here, I'm going to say for each of those particle systems in our particle system array. So particle system, let's just call it parts, or part for particle system, or short for particle system, in our dust trail array, which I just realized I spelled wrong. It should be dust trail, not dust trial. There we go. For each of those, then we're going to use a variable called the emission module, which we have to get from that particular part. So part.emission, because we can't set a value to that directly. We have to set that as a variable. It's one of those weird quirks of the particle system. And then we have the emission module that we just created, rate over time equals the emission rate that we have set here. So that's either 0 or our max emission value, which is a very quick and simple way of just controlling the amount of that's coming out of our particle effect. So now when I save, let's go back to our car and assign these two little dust trails that we have to this. So now I can play and we can drive and turn, and when I stop moving, the dust disappears, but as we drive, they keep blasting out of the back of the car. And you can see when we're in the air, we don't get any dust appearing also. So perfect. There we go. We now have our nice little system working in our car here. So we've got a cool little car controller system. As you can see, not too complicated to set up, but it really allows for a fun feeling experience in your games. And there you go. Thanks for watching this tutorial video. I'll be back soon with more tutorial goodness. In the meantime, don't forget to go to Steam and wishlist Scoot Kaboom today. If you haven't, of course, also make sure you subscribe to the channel. Hit that like button on the video to see more videos just like this if you want to. And keep being awesome, keep making cool games, and really importantly, keep sharing with me the videos, the games that you are working on. If you join our Discord community, you'll see there's a whole bunch of people there adding their own games and showing what they're working on and showing all the cool stuff that's possible to make in Unity. So yeah, thanks for watching. I'll see you all very soon.